force. Gravity is a conservative force. It says that the work done is path independent. Work done is path independent. The work done between the initial point and the final point, doesn't matter how you got there, initial and final, is path independent. Now, is there such a thing as a non-conservative force? As opposed to, let me just start with an example of something on a table. Let's say that, again, your cat is pushing something around on a table. And this is a top view. Let's say that the object is pushed in a straight line of distance d, and we can figure out the work done by the various forces on the object. But let me just compare that to the object being pushed on a different line. And let's say that the object is pushed on a different line. Let's say it's a straight line here of distance 0.7d, and a straight line here of distance 0.7d. Those are meant to be straight lines. Now this is a top view on a table because I want to be able to talk about friction, which, let me jump ahead to the conclusion, friction is a non-conservative force. Let me see what that means. So let's say that your cat pushes your phone on path A, straight line from initial position to final position. How much work is done by the friction if the mass of the phone is m and the coefficient of kinetic friction is mu k? I don't care how much work the cat does, but how much work is done by the friction. The work done by the friction is the magnitude of the frictional force times the magnitude of displacement times the cosine of the angle between the frictional force and the displacement. We'll just call that theta. Just imagine, right, at any point as it's pushed along this path, here's the object, the displacement is in that direction, and the friction is in that direction. So in that case, right, theta is always 180 degrees. Theta is always 180 degrees for, almost always for friction, not always, but for when we're dragging something across the floor, it's always 180 degrees for friction. Okay, what is the magnitude of the frictional force? The magnitude of the frictional force, Ff, is the kinetic frictional force, Ffk, is mu k Fn. Because this is a phone flat on a table, and the cat is just pushing it along the table, in this case, Fn is equal to mg, which is mu k mg, because it's a flat table, etc., because flat table. If you don't know that, you can go back and do your Newton's second law and figure that out, but that's what we end up getting for the kinetic frictional force, the magnitude of the kinetic frictional force. So therefore, the work done by the frictional force is mu k mg d times the cosine of 180 degrees, which is minus 1. So the work done by the frictional force is minus mu k mg d. Now, let me restate, the work done by the frictional force along path A is minus mu k mg d. Now, let's look at path B. And actually, let's just take path B as being half that from there to there. That's path B. And then we'll make this path C. Okay. So path B, we've got the same thing, right? We've got the work done by the friction is the frictional force. The work done by friction is still this. The angle is still that. My displacement is now 0.7d. And the frictional force is still mu k mg. The frictional force doesn't change. So the work done along path B is that. So what's the work done by path C? Along path C. The work done along path C, it's the same. And again, that doesn't matter that path C is an angle to path A. All that matters is the angle between the frictional force and the displacement. So at any point, the displacement is in that direction and the frictional force is in that direction. So it's still 180 degrees, right? 180 degrees. So it doesn't matter that it's at an angle to the original path. We still get that the work done by friction is minus mu k mg, minus mu k mg times 0.7d. Okay, it's a non-conservative nature. Because if the phone starts, I'm going to make this a really messy picture, but the phone starts here and finishes here, what is the total work done to get from I to F? The work done to get from I to F along path A is minus mu k mg d. But I just say total work done or total work done by friction? I meant total work done by friction to get from I to F. And the total work done by friction to get from I to F along path B then C, still going from the same initial position to the same final position, is the work done along path B plus the work done along path C, which is equal to minus 1.4 mu kmgd. Notice that the total work done to go from I to F in this case is minus mgd. In this case is minus 1.4 mgd. Friction is a non-conservative force because it takes a different amount of work if you travel a different path. Gravity, same amount of work if you travel a different path. Friction, different amount of work if you travel a different path. So friction is what's called a non-conservative force, and gravity is a conservative force. Done and done.